Okay, I need you to turn to page 38 in your notebooks, which is standard deviation and variance. Now, we've discussed what standard deviation is. It's just measuring how variable stuff is. Your variance is just your standard deviation squared. So if you need to find that, whatever your standard deviation was, you would square it. Variance is seldom used. We just have to mention what it is. So let me first of all quickly review how to find your standard deviation on the calculator. So I have these numbers. We're going to do that for lot eatery. I have lot eatery numbers put in my calculator. Notice this is a 22.5 and a 27.5. So I'm just going to do stat, one variable statistic for L1. So I entered that in the calculator under the one variable stats. The mean is 25. Okay. I have two different standard deviations. The main one we're going to deal with is the sample, which is 3.95, and you can see right here in the calculator my S, 3.95, and then my population standard deviation, which they gave it, which is a 3.54. So this one right here is from the sample, and this one is from the population. Standard deviation is one of the few things that there's actually a different calculation. But you might want to put a little star by sample, because almost all the time that's the one we're going to use. You seldom know the population standard deviation. Okay, so I'm going to first of all start by giving you the formula for population standard deviation. What we're pretty much trying to find for this data set is which is more variable, Big L's prices or lot eatery's prices. So the formula for your sample standard deviation is the square root of 1 over n minus 1 times the sum. This is summation of each value minus the mean squared. So what I'm going to need to do is find the mean, take each of those values, subtract the mean, and go from there. So from this data set, you can see a couple things. Like pretty much everything goes by 5. 25 is the center. It's the mean. If I needed to put that in my calculator, you would also see that 25 is the mean. N, number of values of the data set, there are 5 scores. So now what I need to do is put these numbers into my formula. So here, got the square root. One thing you're going to notice about standard deviation, it's not necessarily hard, but it is kind of long. So I've got my 5 minus 1. So that is going to be times the sum. Now for each of these values, I'm going to do 15 minus 25 squared plus 20 minus 25 squared plus 25 minus 25 squared. I'm hoping I don't run out of room. Plus, I'm going to go to the next line, 30 minus 25 squared plus 35 minus 25 squared. Now, I ran out of room, but again, note we're going to do all that first. Okay, so then from there, I'm just going to go ahead and do some simplification. So obviously 5 minus 1, I'm multiplying by 1/4. 15 minus 25 is negative 10 squared. So negative 10 squared. If I kept on going, I'd have negative 5 squared plus 0 squared plus positive 5 squared plus 10 squared. So there it fits for me this time. I'm going to continue on. I'm going to have 1/4 times 100 plus 25 plus 0 plus 25 plus 100, which gives me the square root of 1/4 times 250, and that's approximately 7.91. So here, for Big L's Eatery, I have 7.91. Over here, for Lot Eatery, I have 3.95. So if I was to compare the two, I can say that lot eatery prices are more consistent or less variable. So lot eatery prices are more consistent or you could say less variable. Okay, so we kind of went through, we plugged the numbers in the formula. Remember, this is summation. Again, standard deviation isn't necessarily a complicated formula, but it can be tedious.